Okay. So hi, everyone. Thank you for coming tonight. This is our first event for our AMS committee of this semester, which is a machine learning Q&A with our guest speaker, Edward Turner. Thank you so much for agreeing to be a part of this event today. This event will be recorded and posted on YouTube and our website later. And I will turn it to Edward to introduce himself.
Thank you. Thank you very much for turning things over. I'm sure that some of us have already, kind of been bothered by maybe some questions I have to some degree, but I'm a machine learning engineer working currently for Levi Strauss. I'm also a Stony Brook alumni, which is part of the reason why I'm here, to kind of, answer questions and to also provide advice and guidance to the next generation of data scientists and machine learning engineers, hopefully. I've also worked at a couple of different other companies in the past. I worked for Nielsen, which is a media rating company, which I didn't really know what they were doing until I joined their company. But essentially, Nielsen was also a company that did more or less measurements across TV, radio, mobile devices, and different other types of electronic devices as well to help their customers for more or less marketing purposes. So in case you were curious about that, you can look it up on, or I can describe it to you a little bit further, but if we don't get time to that, you can always search it up as well. Now, another company I also worked for was Paylocity, which was a human resources / payroll company. And the primary purpose of that company was to go and essentially develop some type of heuristics for when a person is leaving their a company, not their company specifically, more or less tenure type predictions. So that's more or less my secular background, but I'll dive a little bit more into my academic, since I think that's also part of what we're interested in as well. But largely speaking, a lot of my focus has been purely things that are more mathematically based once I graduated from Stony Brook. And a lot of my a lot of what I wanted to do was mathematically based. And so I've done a few different things. I've actually worked as an instructor at Stony Brook in the past. I've actually taught Calc 1, 2, and 4 during my graduate days. And then I've also taught a couple of different classes at different local community colleges like Suffolk Community College. I taught at the Brentwood campus, also the Selden campus a couple of times. And so, I had a very interesting beginning, which we'll describe more, as we dive into the questionnaire. Now, I apologize for any background noise. I have a very loud friend laughing at a couple of jokes in the background. So if you hear laughter in the background, it's a friend of mine. And so I apologize about that. But essentially, a lot of my overall beginnings have actually started all in New York, where I was living before I decided to migrate afterwards. But I hope that's enough of at least of introduction. I know I'll probably dive down to maybe a couple of things that I know we want to also talk about too. So please stop me, Vivian, if this is going a little bit further and then maybe progressing a bit more than what you intend as an introduction.
No, that was fine. We can move on to like Q&A. Would you prefer like a Q&A style where I ask you the questions?
I think that might be the most useful actually for everyone here. Let me do this. I don't know why my screen isn't, there we go. My camera was showing, but I guess when we started recording, I decided to shut off my camera. So apologize about that. My camera didn't intend to be turned off. But that wasn't intentional. I think that might be a default thing that Zoom is having right now, which I might have to resolve next couple of moments, but that's fine. Whatever is, my thought process is, I can talk at odds length. And so I think it might be useful for us to go over some questions. If you want me to go a little bit more into more of a sequential chronological order of what I've done from Stony Brook to where I am now, I can do that too, which might answer some of the questions as well. So we can, do either of those two things, whichever you see fit. I'm always, flexible with whatever we think is going to be the most important and most helpful for everyone here.
Yeah, of course, that sounds good. We could start with your undergrad. I know one of the questions that was submitted was, what courses at Stony Brook did you feel like prepared you for your current job, or maybe prepared you for the going into the workforce?
Yeah, most certainly. So I mentioned this briefly. I've worked, well, not let me phrase this. I studied pure and applied mathematics in my bachelor's degree program. And I've pretty much, as I mentioned, took every course underneath the catalog outside of logic, MAT 371, and analysis of algorithms was MAT, if I remember, 363. So those are the only two I didn't take. I remember those for a particular reason, because those are the ones I didn't take. I wanted to, but I didn't get the opportunity. And so a lot of my decisions, or a lot of what I learned rather at that time, I would reason was mostly helpful and useful for where I am today, especially from a certain standpoint. And I'll dive into a little bit of that in a few moments, but I will say that there's some courses that, of course, were in particular that were kind of more of a philosophical in nature that I appreciated, but still when it came to the direct application into the field of data and AI, maybe wasn't so directly applicable. And so an example was abstract algebra. So group theory, field theory, all those things, while extremely helpful and useful, that I really appreciated actually, and really used in a lot of other type of philosophical conversations with my coworkers. It only has gone as far as that. And so, in the field of data and AI, it's not as directly applicable yet. I do think that maybe at some point it could be, but in the current state that data and AI is, it may not be exactly applicable for an abstract algebra course. But other things, for example, like set theory, surprisingly set theory. The one course, MAT 200, we may have just kind of hated a little bit and kind of just dealt with it. It's actually a course that actually has been very helpful. The idea of set theory and applying it to even programming concepts and also eventually data and AI concepts has been very helpful for overall conversations and understanding different types of algorithms that are in play. Even MAT 3, if I remember, MAT 361, which is topology and geometry, if I remember that correctly. And also differential geometry, which I forget the exact title. So MAT like 370 something, I forget, either 372 or something like that. I forget the exact course code. And that might have changed, of course, by the time I left. And even topology geometry, I think it might be 360, if I'm 364, if I didn't say that properly. But in any case, those two in particular have actually also been very useful for me, because the idea and concepts of data science is actually very similar to what we do in those two particular courses. Applying a function onto a particular set of information, a set of real numbers that describe some type of, maybe topological shape, and applying it onto another more or less topological shape, whether it's real numbers where you have some type of thresholds and some type of decision boundaries within the field, or even if it's a sigmoid type problem where you're just mapping onto a surface maybe of an object rather than the actual volume, you have that in play as well. And so, those two in particular concepts, while they may not be as directly applicable as, say, maybe calculus, because a lot of calculus concepts are going to be directly applicable to overall data and AI concepts. The concepts that I've learned from topology and differential geometry have actually been very helpful and very useful for me understanding how to push forward into the other concepts and thinking about things from a standpoint that maybe some things that, some of the methodology that we were utilizing across the different companies I was a part of could be further improved on just by really rethinking the mathematical properties of what you're trying to really accomplish and do. So that's more or less the MAT side of things. Of course, there's the AMS side of things, which I'm a double major, so I had the appreciation of both as well. And so definitely for sure, and I see a comment mentioned here with the comparison MAT AMS courses, so thank you for that. So from my AMS side of my undergraduate education, a lot of things I learned there were the direct applications of the concepts, or majority of the concepts I was talking about. Some things in particular are not exactly going to be one-to-one. For example, number theory, MAT 331, not exactly applicable to data and AI. Again, I apologize for the loud noise. Now it's my wife and friend talking in the background, so I apologize about that. But definitely for sure, MAT 331, not directly applicable. Number theory, again, philosophical conversation. I can map the Pythagorean triple onto all the rational points numbers on the unit circle. Awesome, great. Can I apply that to data science? No, not really. Now, a lot of things I've learned and appreciated from AMS can directly apply to data science into how things are typically done. And so, for example, AMS 331, probability theory, has a direct relationship to exactly what I do today. There's a direct relationship there exactly to the statistical probabilistic concepts I rarely utilize in everything I do. Even the concept of optimizing models is purely based off of Bayesian statistics, which, truth be told, isn't taught anywhere in MAT courses. You might have like something, a mathematical seminar, which I took was based off of some, I think, random number theory or something like that, something similar, but it's a seminar. It's not, offered regularly. But AMS has offered courses that directly relates to the concepts and ideas of statistical and probabilistic measures that you only can really use directly within the field of data and AI. Some deterministic stuff from math, MAT, can be applicable, but you can get that also from AMS, as you already know, that there's, direct course equivalences between calculus and MAT and AMS. You get a couple additional things, but even then, like complex analysis is directly, cross-related across different departments. You have real analysis, which is more, if I recall correctly, a MAT class. I forget if there's an AMS equivalent. You can correct me if I'm wrong. You're all students here, so you can tell me what's the most occurrence of Stony Brook. And I rarely accept that too. It's been a few years at this point since I've been able to really entertain myself, and I had some fun with some math courses at the university. But essentially, there's some things, definitely in particular in the EMS, that are only directly applicable to what we do in the field. And that's more or less from the undergrad side of things. I can go into the graduate side of things. I do have my master's degree from Stony Brook as well. But is there any other questions we want to more or less kind of think about and consider before I go on to that? No?
Okay, doesn't seem
Yes.
like it.
All right. So let's see.
Thank you for explaining the difference between the MAT and AMS side of courses. One of the other more popular questions was, I believe you got your master's right after your undergrad, but a lot of students were wondering, is it necessary to get a master's degree? And would you recommend getting a master's straight out of undergrad?
Yes, thank you for that. And I'm also looking at questions too, just to see kind of if there's anything else applicable. So I like to be very thorough in how I answer questions. I want to be sure that everyone is satisfied with the answers too. So I was just looking also at the questions you sent. But yeah, let me go straight to, I think that was question 11 you asked, just do you recommend getting a master's straight out of undergrad? So I'll go with the rationale why I went for my master's degree at first. So I think that might be a better answer to that question. And so my original goal was actually to go to for my PhD in mathematics, uh, specifically in AMS. And so I went to go for that. However, due to restrictions from funding, Dr. Sean Lee was my professor and he wanted sabbatical leave in 2018. And I needed to do a couple of different things, differently. And so there's a couple of more personal reasons why the PhD route wasn't necessarily taken at that particular point. But there were some things in particular I appreciate for the master's degree program that gave me an edge in definitely when I got into the field. That definitely helped me along with the data science concepts and methodologies, along with making a stand and improvement on some methodologies. And so that's the reason why I got my master's degree directly after my bachelor's degree. It was more like on the route to the PhD program that I got it. I do want to be transparent with that with everyone here. But one thing in particular I did appreciate from the master's degree program that at least I was a part of was the numerical analysis courses within AMS. So one thing in particular that the MAT will never be able to teach you is how to apply the concepts that you've learned and the mathematical concepts that you've learned into a real world type setting. So an example, it would be something natural. You might think of the concept called optimization. Being able to perform optimization and on, say, a least squares type model, we have A, X equals B. You want to be able to project A onto B through the variables, through the coefficients X, through linear regression. You want to be able to find those coefficients, the bias. You want to map everything appropriately. So you would use normal least squares regression on that. Normally through that, you would use optimization. And the only way I at least learned optimization was through numerical analysis 1. And that was the course I learned how the mathematical concepts applied and how then you can use different optimization algorithms that you can develop yourself actually directly in a programming language of your choice, whether it's C, Python, Java. You can do it in Haskell if you want to. Don't suggest it, but you can if you want to. But it's something that the concept, at least, I learned in that course that allowed me to at least start on how to think of things more from a computational point of view, from a best practice and best mindset point of view. And so that was the first course. And then I have a couple others that taught me more the differential way of doing things, how to expand upon that and 2D sense, how to explore temporal types, considerations into the field of numerical analysis, but numerical optimization. Look at deep learning. All it is numerical analysis, just applied at a bigger scale, but it's really not that much different. Application, of course, different too. You're not applying it on Newtonian physics. You're not doing that, but you're applying it on things that actually can have a direct impact into our lives. I mean, facial recognition. If anyone has an iPhone 12, there we go, data and AI right there. And so facial recognition right there is definitely a direct application of data and AI. But that's using something you can learn easily, numerical analysis 1, 2, and 3 in the AMS master's degree program, at least the concepts of it and how to build it yourself. At least from the low level mathematical side of things, you can. And so do I recommend getting a master's degree right after undergrad? For the field of data and AI, just to answer that question, because I gave kind of like a long about answer, to this. Sorry, I'm very verbose as well, along with meticulous. So thank you for everyone's patience. But answer that would actually kind of be yes. Not because I feel that in particular, a master's degree is kind of like the gatekeeper, of the job itself, because it's not. I've met a lot of people that I met a few coworkers that actually have never gotten a master's degree, got a bachelor's degree, in mathematics or in statistics, and they're data scientists. And I've met others that actually, quite honestly, don't have a degree at all. Very small select. There's not a lot, but there are some that they're that exist, that they're there in my job currently, and they're data scientists, and they just understand the statistical concepts and analysis of things, and they were able to prove to the hiring managers and everything and say, hey, I know what I'm doing. And they're like, okay, fine, I'll bring you on. And here they are proving themselves. So it's not necessarily, I think, that a master's degree is kind of like the end all be all, and you need it to pass the gatekeepers. I'm not saying it for that reason, but it's a lot of concepts that if you want to be someone that's kind of like the creme of the creme, someone that's like really good, then the concepts you learn in a statistics, data science, applied mathematics type program, you would definitely be able to benefit from that directly, and you'll give yourself more flexibility too. In case, for example, things change in life and you want to switch, like myself, from being a mathematician professor to a data scientist, or to machine learning engineer, you give yourself a little more flexibility for that. But this will definitely help you with your goal, for sure. So that's at least question number 11 there. Let's see. I'm trying to look back at the list right here. Vivian, is there another question that you asked me at the same time? Because I know I probably answered it for sure, but is there another one in particular that you have in mind that you want to pick from the list for me to answer?
A lot of the master's ones were pretty similar, but another question was, how is machine learning like applied at Levi's? Paul asked a question. Is there a specific specialization of the AMS masters that you would recommend?
Yes. All right. So I specialize in computational applied mathematics. That might have been a little bit, self-explanatory when I said I took numerical analysis 1, 2, and 3. They're the only ones really available for that specialization. The specialization I would say that probably the most helpful is really most likely the statistics specialization, because I remember there is the statistics specialization, and probably also the computational, applied mathematics. Operations research is great, and there's definitely a lot of concepts in operation research, very important, that actually are applicable in data science. Actually, I'm working on a project right now, and I know there's a couple of questions regarding that, but I work on a project right now that does essentially time series analysis to help solve a supply and change management problem, which is honestly a operation research type problem, a normal problem statement. And so, operation research is definitely important, but if you're going from a conceptual point of view, there's going to be able to expand and help you in other areas of the field of data and AI. Statistics and computational applied mathematics are your first two, probably to think of first. The other ones are also valuable too, but ironically, I wasn't even aiming for either of those first. I was aiming for quantitative finance. Again, I had another revelation in of myself to, maybe, I should rethink about a couple things. And I love, computational finance. I've took a couple courses for that as well, as electives. Great, wonderful, terrific. Dr. Andrew, I think Murfield or Muller, if I remember correctly. I have to re-look back, but he was a great professor I had. I had to really look back my transcripts for that. But he was a great professor I had that really was also, intellectual, taught about linear algebra and their applications in the field of finance, and a lot of those concepts, because finance talks about a lot of statistical concepts too. And those concepts also apply directly into data science. And so a lot of it is really, related. So there's a lot of things I did learn from that, but statistics and computational applied mathematics will be the ones I would suggest. I also see Zachary, asked the question too, do I feel that a master's in computer science would be more valuable than a master's in AMS for this field? It kind of depends on where you want to go. So there's two different tracks. So I'll talk about this a little bit. So data science, the field of data and AI is a very diverse field. And so there's really more or less three, you can say like there's three different tracks in the field of data and AI. You have data engineers, which is kind of more or less more similar to computer science than data science, but there's a lot of data, concepts you have to learn, and a lot of the skill sets you learn translate into data science and machine learning engineering. So there's a lot of things that translate. Data science is actually a more research-driven field. So there's a lot of companies that try to use data scientists for the same purpose of like data engineers and machine learning engineers. I'll describe what machine learning engineers are in a second. But data science is more a research-driven type position, research-driven type job. And so your focus at that point is going to be getting the data, building models, developing the architecture, making sure things can be validated efficiently and appropriately, and then working with the deployment engineers, which could be the machine learning engineers or the data engineers, to help you make sure that what you've built can go into production. That's, if you have a big enough organization, that's kind of how things are divided. In small organizations, you might have just a data engineer and a data scientist, and the data scientist does what a machine learning engineer would do. Now, machine learning engineer, what their primary focus is some of the deployment. So definitely the deployment is part of it, but also being able to effectively scale and improve a data science methodology. And so an example would be, let's say we had the data scientist built a model based off of data that can fit on your computer, can fit in RAM, so to speak. And that's kind of the way they've done things at first. However, in production, which is a problem dealing with right now, sometimes data science models can't scale to the data that you're going to eventually read in from different databases, different data sources. And so a lot of times some data science models fail to scale according to the data you have. And so the machine learning engineer helps take the modeling process and helps it to scale to the data that is in the input systems. Then along implying different other concepts such as machine learning model life cycles, which is similar to software life cycles, but you apply it to the machine learning model architecture more specifically, and along with measuring what's called drifts, which is more or less measures of which how the data, or not just data, kind of deprecates over time, and maybe the measures and statistical aspects of the data is changing over time. That's going to affect the model. So that's one part. The other part too is how well is the model predicting on it? Is it generalizing well? And so you have the train, test, validation splits you normally do during training, but now you have to measure that across time as long as you're using the model. And so those are the three different types of more or less, kind of silos or kind of descriptions in the field of data and AI as a whole. And there's a few others too, because you have more support related jobs like QA, operations, DevOps, software engineers. You have to integrate with the web developers too. So there's a lot of things you have to sometimes work with and learn as you're working in the field of data and AI. But those are the three primary suspects. But computer science, I would reason at this point, is great for the data engineering and for the machine learning engineering fields more so, because a lot of the concepts you're really employing there are more software related, and especially for the data engineering jobs, because that's very software related. Machine learning, you still employ some statistical concepts. I'm redefining models as we speak that are built using one framework into another, just because of scalability purposes and use of transfer learning and a couple other pretty decent data science concepts. But that's the primary reason. So machine learning engineers are you can think of as data scientists with software engineering more specific skill sets. So that's kind of like the division right there. So hope to answer your question, Zachary, but that's kind of like the more or less breakdown between the three different main suspects, and where the master's in computer science really be applicable towards. So let's see, I'm trying to look at the question list here too. I know we have a lot and I've spoken enough, and we have about maybe 12 minutes left. So let's see. So let me just go through some of the questions then here, one by one, if that's fine, Vivian.
Yeah, that's fine.
All right, so I'll read them off. That way we kind of know which ones I'm trying to answer, because no one can read my mind. So I'll do that. What percentage of skills knowledge do I use at work on a daily basis would you say you learn on the job? 100%. About 100% of those. I'll say, all right, let me rephrase, 99%. The 1% I learn is the math stuff that I can't learn in a job. But the technical stuff, such as Spark, Apache Spark, how do I use it? Cloud technologies. You don't learn that in college. I taught that myself. I'm certified in AWS. I'm trained to be certified in Google Cloud. And so those I'm learning on my own. Spark, I went through boot camps to be certified. I haven't took the exam, but I should, but that's something I'm more or less trained as well. So those particular, like frameworks and cloud technologies, I had to learn on the job, which is about basically 95% of my job. The other part of my job, the other, I guess 3-4%, is actually more driven in not just software concepts, because that's part of it, but also architectural concepts, because a lot of things you don't learn even really so much in computer science, because in computer science you learn more the software design, but architectural design of systems and how they integrate with the software, integrates them with, if you're in data and AI, how to integrate with data and AI concepts, how you interface with stakeholders. A lot of those things you're not going to learn in college. It's going to be learned on the job. Even if you're a software engineer, you're not really going to learn those concepts immediately. And so that's something you learn on the job. Let's see. So hopefully I answered that question appropriately. If anyone has needs a further clarification, please interrupt me and do so. Yes, thank you, Vivian. And so thank you, Vivian, for putting that in the chat so everyone can keep in touch. Now, how do I improve my machine learning skills? Honestly, Kaggle, just Kaggle and reading. Some of this is sometimes just based on projects that you just work on. So if you know Kaggle, you have the Titanic data set, you have your house real estate data sets. You work on those to build a model based off of that to do X, Y, and Z. And so that's definitely part of it. But Kaggle for sure has taught me a lot from when are things applicable, when are things of best practice to be used. Another thing I guess I would kind of add to that as well, and I'll add here as well, because this is kind of a continuing education point for myself. I did take a couple things from Coursera. Coursera is essentially, a massive online, course platform that I took a course in statistics for applying to R. So a lot of things I learned from Stony Brook, but I did take some things and said to myself, I need to learn how to apply this in some programming language that's, that's not, C and Java. And Stony Brook didn't have a lot, at least during my time, didn't have a lot of R, Python courses available. And so I had to, look towards outside sources. So I took Coursera, looked at that, got certification dealing with statistics, specializing in R. So that's one. I took some more Coursera course in here, but nothing, generalized into a specialization. And currently I'm actually in a master's in artificial intelligence program. I'm continuing my education as we're speaking. So it's a continual process. I'm students just like you right now. So we're not that much different. But it's something you continually apply, continually learn. You're never in a state where you're the expert. Yeah, you're always learning. You're always a student. Now, which fields I can apply machine learning in? I would say just about everything at this point. I don't know if you know this, but you can apply it in healthcare. Finance definitely is one of them. I'm in real estate right now. I'm in real estate retail, but you can apply it in real estate too. You can apply it in an advertisement, as you can kind of tell from Nielsen's market research company. So apply it there. Apply it in human resources and human resources and payroll. I'm also even applying it right now in a separate project, my own personal one, where I'm doing a NLP on top of actually an artist. I'm pretty sure someone has heard at some point the ghostwriter for Taylor Swift, and they were able to build a model to kind of project a sequence that you've of sentences onto a Taylor Swift lyric and make you sound like you're Taylor Swift. So there's some things like that. And I'm working on that right now for a couple things, and along with building some type of auto encoding where you can map winter to winter and images, and so you can map New York, Central Park, summer, try to map it to winter, see what it looks like, and give some very interesting colors. And so there's a lot of fields you can apply this to. It's just where your creativity sits. Oh, thank you for the question. Explaining how ML is applied at Levi's. Thank you for that. So there's a lot of things in particular at Levi's that we apply ML. In particular, one is so it's two projects I'm on. One is recommendation. So recommending a product to a person. How can you when can you base that off of? And so, of course, you can give the methodology, but definitely the general concepts is applying some type of new, nearest neighbors variant type algorithm onto past histories of information and then projecting that onto the user to state whether there is a brand new product that they might be interested in purchasing or viewing. And that can come in forms of whether ads directly on the website or through an email if you subscribed and okay to receiving emails. And so that's one particular application. Another one is actually another project I'm on that I'm leading is time series forecasting on supply chain management. And so can we predict into the future that that a particular store is going to have a demand for different products at different times throughout the year, and whether the demand is above our threshold or below our threshold, what we think, what the experts, product analysts are saying, maybe what's not. So there's adjusted demand, and that's what we're calling it, adjusted demand of products and how we're predict that. The other one, sellout, which is how can we predict that our product can sell out at different stores. A little bit different concept. We're predicting more whether there's something is zero or above zero, whichever way you want to look at it. And that's more of a classification problem. The other one's more of a linear regression type problem. Not strictly linear regression, but a linear GML, more or less, a general linear model that we're trying to predict there. There's other models that we're using too, such as propensity, which is basically predicting the likelihood someone's going to respond to an email given X, Y, and Z. So there's a few different models in advance. And sorry for the salsa in the background. I apologize about that. But that's more or less a few different types of use cases, and that's just this handful that I'm aware of because those are the three projects I'm part of. There's others that are like predicting inventory based on statistical inferencing and stuff like that across different products. And this is rarely applied, not just in US, but also in Europe and Asia too. So these are, more or less methodologies applied across the world at Levi's. So that's at Levi's. At Nielsen, I'll start a little bit at Nielsen as well, because I want to be a little more, inclusive with my previous experiences. Nielsen is predicting whether someone was going to view a particular show at a particular point in life, or how many minutes someone's going to view a channel at a particular time. And so basically the viewpoint Nielsen was combining the media universe together into one data set. So an advertiser can see whether you're going to view a particular channel or whether you're going to watch, how many minutes of a particular channel, just estimations, not exact, but just to give advertisers a kind of view and kind of how that's going to be. And so that's at Nielsen. At Paylocity, the goal was to predict whether someone's going to leave a company at a particular time. Of course, they didn't predict that with me, but that's because the methodology was evolving. And that's kind of a joke a little bit since I've changed companies at that current point. But that was the goal, and they applied that, and so it's working pretty well there right now. But that's kind of the three different ways that we've applied ML at least the three different places I worked at, but more specifically Levi's, a little more top heavy Levi's, but that's kind of more as we applied there. This answer the question properly. I know we're about 10 minutes shy towards the end. I want to be sure that we all have time to go in that. Oh yes, please go ahead, ask a question. You can interrupt me.
Hi. So I just transferred to Stony Brook as a pure math major, and previously I was really focused in computer science. I'm a full stack developer, and I'm also certificated in AWS. Recently, I just finished the Google certificate program in Coursera, so I'm just like dipping my head in the data field. And for me to have a standing out resume as a data analyst or a machine learning engineer, what would you recommend me for the next steps? Should I like either have, maybe many little Kaggle competition or projects, or should I maybe utilize my skills and then make some giant, website that utilizes the machine learning and data analysis steps?
Thank you for that question. I appreciate that, and that's a good question too. One thing in particular I do on a regular basis, and something I'm doing tomorrow, is interview candidates. I interview candidates every week, at least one or two. And so I'm probably the good person to ask you that type of to answer that type of question for you. So it's great that you have experience as a full stack engineer. That's something that it's very encouraging to see. I love the diversity of overall experience, because that's going to give you more insights into how to build applications, which if you really think about software engineer machine learning engineer is really just an application of a software engineer into the field data. It's really not that much different outside of concepts and ideas that you apply outside of the statistical nature of some models and some things you have to keep in mind. So, to answer your question more directly, I think you're on a great start. I think having a portfolio of some of your work is going to be very important. And also trying to keep in mind the difference between a software, a machine learning engineer and a data scientist. I interviewed a candidate recently that had a great portfolio for a data science, type position. Very intelligent. I was very happy that she had that experience, and had great actually connections to building a deep learning model that was injected into a web application that was going to be put onto Android applications. And so great experience. I was really happy to see that. However, a machine learning engineer doesn't always just builds the model and hands the model off to someone as a waterfall, throwing over a fence. That's not what we do. We not only sometimes can build models, which we're all equipped to do so, but we also take those models and build pipelines off those models, which whether streaming models or batch process, which batch just basically means we read a bunch of rows of information, process it, feed into the model, and spit those rows out somewhere else. It's batching, and streaming as we take one row at a time and pass it on to a model. That's the two differences. And so a machine learning engineer is focused on one of those two. And so I think one thing in particular for you when you're looking for machine learning engineering positions is to kind of keep in mind when you're building your portfolio, think of, not only building the model, which is really important to display because you have to show you can do what data scientists can do as a machine learning engineer, but also can you go and take something and showcase how you can do it in some aspect of, some type of production, not production system, some type of predicting system, whether it's in batch or it's streaming. And this could just be building a Flask application, reading your model using, you pickle your model you saved and you train, you read it in through pickling, you submit output to a particular, REST, a post, doing a post request to some REST API. You feed the information there, you get the predictions, and you get that, and it feeds back into your front end. So that's typically what you can do with a showcase. And so I would really think for your particular case, have a combination. Have one thing where you have some like static, type of website, which could be through Jupyter. It could be just kind of Jupyter notebooks or output files from HTML from Jupyter. Showcases your experimentation, your thought process. This is really more a general concept for everyone too, that's especially looking for the field. You can apply that, and that'd be directly useful and helpful to demonstrate your experience and your expertise, and definitely the field of data as a whole. But for machine learning engineers in particular, the next step you can also take is also describing, rather demonstrating how you can do that through like a web application like Flask, or whichever one you prefer within Python, or if you're full stack engineer, so I'm assuming you also work with JavaScript too. So if you're using TensorFlow, you can download the model as a TensorFlow object using the .h5 file suffix, and then use TensorFlow Lite, TensorFlow -JS JavaScript library, read the TensorFlow model in, do your predictions, and go from there. So I hope that answers your question. I might be, a little verbose, but I'm hoping to kind of, get through all the corners and, and make sure I answer your question appropriately.
Yeah, it does. Thanks.
Now you're welcome. Now see another question here. What can I expect? Thank you, Zachary, for another question. So what can I expect from a technical interview at an MLE? So again, another perfect question for me, since I do this frequently. It depends on the company. Truthfully. So I've given interviews to different, candidates that are pure programming based. Can you tell me how to reverse a list in Python? Example, can you show me very basic stuff, but I need to understand, the basics of Python, because truth be told, data science field is constantly evolving. And so you need to understand the basics before you can tackle the advanced, because the advanced will always evolve, but the advanced are based off the basics. Like for example, Apache Airflow is a workflow orchestration tool that data scientists use, that data and AI use to help orchestrate cron jobs, basically schedule tasks, schedule data and ML, processes to run at scale. And it went through a recent change. It went from, a big, major jump from 1.10.3 to 2.1.3, which you might think numerically is not a big jump, but from how you use the tool perspective, it's a pretty significant jump. And overall APIs how you use. Some things are no longer valid. You have to really restructure how you do things. And so from a application point of view, it's going to change, but if you get the lower stuff, it's helpful. But that's one. The other is more what I do, which is actually a management of architectural, and I test architectural ideas. So can you spit to me, if I were to give you a background of a data center methodology, tell you what's needed and required, can you give to me an architecture that could work? Can you describe to me an architecture that can work with different tools that can be used in the cloud, preferably? So that's some of what I use. So definitely an understanding of cloud is going to be useful as a machine learning engineer. Data science, I will say that if you're starting off in the field of data AI and you want to be a data scientist first, you have more flexibility to be able to learn more rather than as a machine learning engineer. That's just more of a transparent comment, because that's been my experience overall. Again, sorry, my friend and wife are very loud right now. They're having too much fun back there without me. But essentially, the field as a machine learning engineer, you have to be more technical. So I would suggest if you want to ease your way into cloud, go first as entry-level data scientist and then go from there. Now I see another question. Thank you, Paul. I want to answer these questions appropriately. How do you recommend figuring out what you're good / want to do? It's a very good question. That's something you have to kind of figure out as you go. I'm sorry, I can't help you with that one. There's some things I've learned that I'm more good at. I wanted to be a research-driven, data science. That's what I'm going back for in school, to be more research-driven. My goal is actually to get my doctorates in computer science, specializing in data science. I already have my master's in applied mathematics, so I'm already mathy. So I'm shooting for that. But right now, as it currently stands, I'm very technical. I have a lot more technical proficiency, and so and that's something I learned 2 years ago, not when I started. So I learned 2 years ago. So some of that you're going to have to learn, so to speak, on the job. It's going to be one of the things on the job, not just the skills, but what your preference is going to be. Are you going to be research driven, technical driven? You have to kind of do some self-discovery there with that. So I can't answer that question for you, Zachary. That's something you have to learn on your own. I mean, Paul, excuse me for that. So Paul, you have to learn that on your own. And that's why I translate as a math major. But don't regret. I love being a math major. Keep doing that. All right, so do you have any tips for applying for internships? If you're applying for internship at Levi, let me know. Go to me directly and I can refer you. Just first look in the website first. If you're on the website and you see there's internship open for as a data science or machine learning engineer, let me know. I actually had an internship open this past summer, and I mentored an intern this past summer. You might have me, who knows? Just look it up and check it out, and let me know. If you're looking for something that if you find something you like, say like Nielsen or Paylocity, let me know. I still have a couple contacts over there too. I can at least pass the name along and try to get things working, and I can pass the name along back to you guys as well. So if you find something on either of those three companies, I can help you guys directly. Thank you, Zachary, for answering that. So I think up front, it might be easier to contact me directly through LinkedIn for some, like for example, for Nielsen Paylocity, it might be easier. For Levi's, you could use my Levi's email, which I will provide here. So I'll put that in the chat window right now so everyone can see. And Vivian, I don't know if everyone's going to see it because we're recording, but maybe not all of the chat will be recorded too. So you can always pass it along to the rest of the members of the math club as well.
Of course.
So let me pass that along right now. So.
Do you mind if I share? Oh, sorry. Do you mind if I share your LinkedIn too?
Oh yeah, go ahead. Please share my LinkedIn. The more the merrier.
Thank you. Go ahead.
I guess with those questions, thank you, that the other students are asking, there was an option to include your resume when applying for this, registering for this Zoom meet. And I actually wanted to send a more refined resume because the PDF transfer was poor in formatting. So I wanted to send it again, if that's okay.
I mean, if you're asking me, sure. I'm very relaxed, very chill. So go ahead, please refine it if you want to. Nothing submitted, I'm not official. So go ahead.
Thank you.
Also, what is the most, how should I say it? What is the most important aspect when you look at interviewing people? Soft skills, math skills?
I mean, it's a balancing act. That's a good question. It's a very good question, actually, because it really depends. So one of the candidates I recently interviewed, great data scientist, great soft skills too. And I would have been okay with passing on the hard skills a little bit if I was able to get to a particular winner. She just felt uncomfortable just from the fact that she didn't feel that she had the technical skills to continue on. But I think truly that it really just depends on the candidate, because there's some candidates that are like top notch, really good. I would say better than me. And I say that about only a really handful of people, and not to toot my own horn, but I say that really only about a handful of people. I hold a high standard for myself, and so and their soft skills were pretty poor, and that leads to different problems. And there's actually, not through me, but there's been other people in the data science team that I work closely with that we're talking to candidates that great, awesome, terrific, but did not have the right team dynamics, soft skills that they were looking for that would make people feel uncomfortable. So they didn't bring them on. So there's definitely going to be a mixture. Soft skills are important. And I think a measure of being able to at least be a human, is definitely part of it. So if you can be a human, I think that you win over half the battle. The other half is going to be the technical stuff too, but I think being a human at least gets a level of compassion from the interviewer to say, all right, Ed may not be the greatest Python developer in the world, but he sees me as a person, so I'm moving forward. But definitely soft skills are important. But I would also say that it depends, of course, on what level position you're shooting for. So if you're shooting for like a lead machine learning engineer or a lead data scientist, your tech stuff has to be on par. You have to be nothing less than what you expect. The moment you show any entry level or associate level type concepts and ideas, that's it for me. And I interview people that are leads. I'm not lead by title, but I do lead on projects, and there are people that do not have lead general skill sets. The people that do, and I pass them on. There's people that aren't, and I don't. And so it's definitely for sure so it really depends, of course, on which tier you're shooting for entry level. I think if you are able to do things with Jupyter and you're able to showcase the skill sets, and if you're aiming for machine learning engineer, then if you can showcase, you can at least deploy a base model using Flask, then that probably would be a good baseline. But if you're a data scientist, if you can showcase the data science methodology, but an architecture, you can show it through Jupyter, you can talk about the data and how you fixed the data and processed it and did your feature engineering, your machine learning engineering, or machine learning model training and validations. And if you can show that, then I think that would be a good start for you too. So that's kind of like the division right there. If you're into data engineering, I don't really have much to say about that. I'm sorry. Data engineering is something it's very software engineering specific, very tool specific. Big data is definitely a thing. And so there's different languages involved. So I can't give too much commentary about that. But for data science, machine learning engineering, I can tell you for a fact, those are the two things I would direct you towards. But thank you for that. Now I know we're overtime, aren't we, Vivian? Or
Yes, we are. But does anyone else have any last minute questions?
I know we only covered about a little less than half the questions on the list. Maybe because I'm too verbose, we didn't get through as far as we could. So I apologize about that. But yeah, if you guys have any questions, I have time for one or two more.
Not really a serious one, but I had a call with my friend. I'm doing a project with him about data analysis, and he wanted to do something shiny that not much people did. And I actually followed him because I thought instead of what we're doing, it's the process, how we show our process of the analysis that's important. Do you have any saying on that?
Yes. What got me my job at Nielsen wasn't what I did for my projects, my profile, but was how I explained it. And that's kind of what got me there. And the same thing with Levi's too. What got me there was how I explained how I did things, not what I did, but how I explained it, and how what I did was going to also be relevant to what they're looking for. So they're looking for someone that was, able to not just build pipelines, but also break things down in an architectural point of view, software point of view that makes sense, that's easily readable, transferable, maintainable. and I was able to do all those things. And so I wouldn't necessarily say, think of, oh, I have to build some type of model that is like a 16 layer, architecture of a deep learning model that takes X to Y and flips it to Z, that while that can be cool, and that definitely might be an idea maybe for a business venture for yourself at one point, for definitely some positions, what matters the most is your thought process. It's how you've been able to think about the problem, think about the data, how that relates to your data science problem, and how you can trickle that forward. And so that's kind of, what you have to really more think of. And seeing your response, it seems like you're already doing that. So just keep that up and keep tackling data science problems and keep moving forward, and you'll be fine. And Zachary, to your question, am I happy with my work and compensation? And that's a very good question. Yes, I am for both. Levi has been very generous with both and how I've been able to manage things for work and also compensation. That's not going to be true for every company. And entry level wise, depending on where you start, you're going to see that some companies pay a little bit lower historically in comparison to others. And that's something you're going to learn through research and also through experience. You can look this on Glassdoor. It's not really much of a mystery, but like Nielsen pays a little bit lower in comparison to the market. Levi's pays close to the market. So your Paylocity pays close to the market. VMware pays closer, but United Healthcare pays lower than market. And also United Airlines pays lower than market for certain positions. And so what's going to be most important is not necessarily always just the compensation. If you can compensation and work, you're winning, you are. But what's going to be important is not just compensation. That's going to be important because you have to pay your bills at some point. We all live here. None of us are living for free. But definitely for sure, how you feel at your job is going to be important. Can you manage being there? Can you manage being with someone that is going to manage you? And that's going to be how you're going to be able to pull through. And a lot of times the compensation will change over time. It's not really going to be, once you stick for a job, it's not forever you're there. I mean, we're in the age where we switch jobs once every, 2-3 years, really. We might say somewhere for 5-10 years, but, starting off, we might maybe change them more frequently. So that's going to change. But personally, I'll say for myself, Zachary, yes, I am happy with both, but giving you a roundabout answer, not roundabout, but a more complete round answer, that's not going to be true for every company. And I can also say from my own personal experience that wasn't always true. And so that's something you're going to have to learn on your own, and something you have to do additional research on. So I hope I answered your question there.
I actually had one more question. My friend, he actually works at Nielsen under the position of a data analyst. He doesn't come from a math background though, and his job doesn't require that much quantitative analysis. So in regards to the position of a data scientist and data analyst, some companies will use the two terms interchangeably. So what is something to keep in mind when applying to positions that could potentially be more data analysis based rather than data science?
That's a very good question. Yes, that term is normally interchangeably used and confused, and along with the same with the machine engineer and data scientists. So data analysts and data scientists are different from the standpoint of what their focus is. So data scientist looks to build new methodologies. Data analysts can build new methodologies. They have the skill sets, they have the knowledge, they know math just as much as a data scientist. There's not really much of a difference between data analysts and scientists from education. But the difference is the focus. And so data analyst is going to be primarily more focused on really say analyzing at Nielsen, more specific in Nielsen terms, maybe the reach in impressions of a particular advertisement network, rather than can we predict the next reach and impressions of an advertised network, which a data scientist or be more concerned about, which I've done that also at Nielsen. So that's the main difference right there. It's the difference is analyzing the information that you currently have and then making the projections. And that's kind of like the more distinct, the difference. They can do either or, quite honestly. Again, the skill sets are very similar. And data science can do analyst work and the analyst can do data scientist work. It's really not that much different, but from a skill set point of view, but the focus is definitely different.
Thank you.
Yeah, you're welcome.
Okay, if anyone else doesn't have any questions, I think we can wrap up.
Going once, twice. All right, sold to the highest bidder. All right.
All right.
Well,
Yeah. Oh, sorry.
Oh no, you're fine. You're fine, Vivian. I was just going to thank everyone. I know we didn't get through everything too, so you have my LinkedIn, you have my email, my work email, and I'm sure through my LinkedIn you can find my personal one too. So if there's another question you might have, or you're interested in Levi's all, let me know. Email me directly, and I'll see what I do. And definitely once you guys graduate, I'll keep an eye out, for me. And we'll see what we can do.
Yeah, of course. Okay. Thank you everyone for coming to the event tonight. I hope you learned a lot from Edward. I also will put the link to the Google form if you would still like to submit your resume, and the link to our website if you want to check out our other events. Next Wednesday, we have a data scientist from IBM coming to speak. So maybe you can compare his experiences to today's event. And then the week after, we have an actuary from Guardian Life coming in to speak, both of which are SBU alum as well. And I'm going to stop the recording.